Hi guys, in this video I'm going to show you how to configure Cisco SD-WAN DIA, that is Direct Internet Access. DIA config we do in order to give internet access to guest users connected on the LAN, or any LAN users require internet access to reach application hosted in the cloud environment. This is the topology I'm using in the lab. I have three VHs, VHS1, VH2 and VH3. And in VH3 I have one MPLS interface, one interface connected to internet. So in VH3 I'm going to configure the DIA. So how we do achieve the DIA setup is like when the traffic coming from your service VPN destined for internet, we send the traffic from the service VPN to VPN 0 NAT enabled interface. From there the web traffic goes to a public internet. So when that internet traffic comes from your users, it reaches the service VPN. There we apply a NAT DIA route or a centralized data policy, so that it will get routed to VPN 0 NAT enabled interface, and then from there we have a static route to reach the public internet. So Cisco SD-WAN DIA configuration we can do using a centralized data policy to send web traffic from a service side VPN to internet transport VPN. That is one method. Or we can configure a NAT DIA route on a service VPN itself to send the web traffic from a service side VPN to internet transport VPN. So in the lab topology, on VH3 under VPN 0, I have one link to MPLS, the private link, and I have another link to the public internet. And under VPN 10 I have two interfaces, one with subnet 192.168.3.1 and 192.168.30.1. So I'm going to configure a centralized data policy to allow internet access for the users under this subnet 192.168.3.1/24. That is these two machines I have in the lab, 3.4 and 3.8. So from VH3, from both the subnets 3.1 and 30.1, they all can reach the overlay subnets, that is LAN to LAN reachability from VH3 to VH1 and VH3 to VH2 we can reach, but the internet traffic we allow only for 192.168.3.1. So when you initiate a ping from this subnet, you can reach the internet public IPs. From under the same VPN 10, if the traffic comes from 192.168.30.1, we allow the traffic only to our overlay prefixes, not to the internet. First we will configure a separate device template for VH3. In VH3 under VPN 0 we have two WAN links, one MPLS link and one public internet link. This public internet link we will enable the NAT, and under VPN 10 we have two interfaces, one with subnet 3.1 and another with subnet 30.1. So once the device template is completed, we will configure a centralized data policy to achieve the DIA requirement, and in the policy we will specify the users under this subnet 192.168.3.1 alone will get internet access. Now I am in vManage console. I'm going to configure a new device template for our DIA setup. For system template, I'm using already an existing template. For OMP also, I'm having a existing template. I'm using that. So we are going to change and create a new template for VPN 0 and service VPN. So under VPN 0, I'm going to create a new template. I'm going to name it DIA VPN 0 VPN template. So the VPN 0 number already taken. And just configure the DNS for device specific. So under the new IP route, we have to add a 2 default route here. And we will add 2 nest hop. So if you see the topology for VH3, we have one MPLS link and one public internet link. So first I'll give a default route to our MPLS link, that is 50.50.1.1. Then I'll add next one. This is for our internet. I'm giving 10.127.201.1. So I'm going to click add and again add. So under VPN 0, this config is enough. I'm going to save this. And VPN interface, I'm going to add a new interface. So I will name it WAN 1 VPN 0 MPLS link interface. So tunnel I'm globally enabling. So color I'll choose MPLS for this. So this MPLS link I'm not enabling the NAT. Duplex I'll give full duplex. Okay, I'm going to save this. So under transport VPN, I'm going to add one more interface. I'll get a new template for that. I call it WAN 2 VPN 0 DIA. So for a second link, I'm giving globally on. So the color here, globally I'm giving public internet. This is our DIA link. So under NAT, we have to globally enable the NAT. So refresh mode, globally I'm giving bidirectional, and log NAT flow creation deletion, I'm globally making it on so that we can see the NAT translations. Block ICMP is on, I'm going to globally off that, and respond to ping I'm going to globally make it on. So that's the NAT configuration. So I'm switching on the NAT refresh mode. I given bidirectional. I'm logging the NAT flows, and block ICMP given off, and respond to ping are given on. Rest everything is same. So duplex, I always give full duplex, and that's it. I'm going to save this. This is the WAN 2 interface. So I have one interface for WAN 1 and another interface WAN 2 under VPN 0. One is for MPLS, another is for DI internet link. And management, I already have a template. I'm just calling them. So I'm going to create a service VPN now. Create a new template for DIA setup. DIA VPN 10 VPN template. So the VPN number I'm changing to 10. So the OMP I'm just giving static connected OSPF on. I'm not touching anything else. I'm just creating it. So under service VPN 10, I'm adding a new interface. So I'll create a new interface template. So this will be VPN 10 interface 1. So I configured device specific interface name, static IP address. So under the service VPN, under VPN 10 alone, I'm adding one more interface. So VPN 10 interface 2 interface template. So the second interface, I configure the same. I will enter the details when it asking. So our device template is ready now. I have configured a new VPN 0 interface template and 2 interface under VPN 0 and VPN 10 VPN template under the 2 interfaces. So I'm going to create this device template now. So now our new DIA VH3 device template is ready. We have to attach it to VH3 now. So branch VH3, I'm attaching it. So I'm going to enter the device template details. I'm going to stop the video and then enter all the details. So I have entered all the details as per our topology, 2 LAN interfaces and 2 WAN interfaces. So now I'm going to attach this to VH3. Yeah, our configuration is attached to VH3 now. Now let's verify the configuration under VH3. Under VPN 0, we can see there are two interfaces. One interface gig is 0/0, and that is with color MPLS, and there is another interface gig is 0/2, in which we have enabled the NAT configuration and we have given the color public internet. And we have two static default route, one towards your MPLS provider and another to public internet. Under VPN 10 also we have two links. One interface is for users which are access only to the overlay traffic, and we have another interface under VPN 10. So we will enable DIA, the internet access, only for this prefix. Now let's configure the policy to achieve our DIA setup. Let's go to configuration and policies, and under centralized policy I'm adding a new policy. So first step in creating the centralized policy is to create a group of interest. So first we have to create a data prefix. I already created this, one for your overlay traffic and one for VPN 10 users. So under overlay traffic, so we have to mention all the destination prefixes in your overlay network. That is the LAN prefixes under VPN 10 for VH1, VH2 and VH3 I have given here under overlay traffic. And under VPN 10 internet users I given only one prefix, that is 192.168.3.0/24. That is under VH3 we are configuring the direct internet access only for the users under 192.168.3.1/24. So that prefix alone I have given VPN 10 internet user. So next we have site. I already configured. Our VH3 is under site 300. You can see VH3 under site 300. And TLOC, I already created a TLOC for VH3. TLOC is nothing but the system IP, the color, public internet, and the encapsulation IPsec. And VPN, we have VPN 10 and 20. In our lab setup, this demo, I'm using only VPN 10. So VPN 10 is already there. So I'm going next. So we are not creating any topology here, so we can give next again. So under traffic data, click on add policy, create new one. So I'm going to give a name DIA VH3 1. So I'm going to click on sequence type and select custom. First we create a sequence rule matching the destination data prefix, that is overlay traffic. So first we create a sequence rule to allow traffic to reach all the overlay IP addresses from our service VPN. So the action I'll give accept. So this is our first rule. I'm giving save, match and action. I'm going to add one more rule. So now I'm going to match the source data prefix, that is VPN 10 internet user. So when the traffic coming from VPN 10 internet users, I'm going to set the action accept. When you click on accept, you can see these all options are getting enabled. I'm going to click on NAT VPN. So this rule simply says any traffic coming from this particular source, send that traffic to VPN 0 NAT enabled interface. So I'm going to give save, match in action. And the third rule, I'm going to set the TLOC. So again I'm going to match source data prefix VPN 10 user, action, selecting the NAT VPN and also local TLOC. So local TLOC that we have set is public internet. And you can give save match in action. So we have three sequence rule here. The first one to allow um, traffic to any destination in your overlay network, that is your private network. And second rule is to match the source data prefix and action, send them to NAT VPN 0. The third rule is also same, matching the same source internet users, accept NAT VPN 0 and setting the TLOC for public internet. And at the end you have default action reject, so we have to go and click on accept. So now we can give save data policy, give next. So this is the actual policy name. I'm going to give DIA VH31 and click on traffic data, click on new site list and the VPN list. So here you can see from service, so we are going to select from this particular site 300 is nothing but VH3, and select the VPN list, that is for VPN 10. Click on add. Now we can preview our policy. So the data policy matching the sequence for the destination of overlay traffic, accept, and source data prefix VPN 10 users, accept and send it to NAT VPN 0, and again same source VPN 10 users, NAT VPN, and setting the TLOC public internet, and then mainly default action accept. So this is nothing but our overlay traffic list, data prefix list, and VPN 10 internet list, site ID, VPN ID, and applying the policy for this particular site. So in our lab we have only one VH, so I'm using only one site ID. In case if you want to apply for multiple sites, you can add here. So I'm going to save the policy now. So before I apply the policy, so I'm in VH3 and I'm getting two routes from VH1 and VH2. So I'm in VH3. I'm receiving the routes from VH1 192.168.10.1 and 172.168.10.1, and I can ping. I'm initiating a ping from VH3 towards DC VH2 172.168.10 IP address with a source of 3.1, that is this interface 3.1, and I'm able to ping. And now I'm going to initiate with the different subnet 30.1, that is nothing but this interface 30.1. So 3.1, I will initiate a ping to any public IP like 8.8.8. So right now I'm not able to reach. Same with 30.1 also. So once we apply our policy, we should be able to reach. So this is one of the machine I have in a VH3 connected to the subnet 192.168.3.1. You can verify its IP once. So this machine is having 3.4 IP address. So from 3.4, I will initiate a ping to the VH2. So I'm able to ping. I'll do a trace path to that IP. Trace path to 10.1. So it goes via 3.1, our gateway, and also trace path to our VH2 172.168.10.1. So again it goes. So the same trace path, if I do for a public IP, it won't go now. So now before we apply our DIA policy, let's see the current simulation for branch VH3. So from VPN 10, from interface 3.1, we'll try to reach destination in our overlay network 172.168.10.1. So it goes via MPLS and comes back in MPLS, and I'll change the destination to any public IP like 8.8.8. So right now it's not able to reach. So now I'll go to the policy and then apply the policy. So DIA VH3 policy I'm going to apply. So once the policy gets activated, we will be able to reach the public internet. Okay, now the policy is applied. Let's check from the machine we were checking earlier. So now we are able to ping the public IP, and we'll check from the browser also. And now we can see the internet access is there. We are able to open different websites. We see from branch 3. So now I will initiate a ping from 3.1 towards the public IP. So now you can see I'm able to ping using VPN 10 source IP 3.1, that is this subnet for which we wanted the internet access 192.168.3.1. Now I will initiate a ping from 30.1 and see whether it goes. Yeah, you can see from the ping towards the same IP under the same VPN 10 source, if I give 30.1, the destination is unreachable. Now let's verify the simulation also. I'll go to VH3, troubleshooting, simulate flows, VPN 10, and I'm giving 3.1, the destination, same destination I'm giving 8.8.8. So now you can see it is going out of interface Gigi 0/2, which is the NAT enabled VPN 0 interface, and the gateway IP also you can see. And if I change the destination to any overlay network IP address like 172.168.10.1, and now it takes the MPLS link. Now let's see the NAT translations. Go to networks again for branch 3, real time. Just click on NAT. Click on the NAT filters and give the filter values. So the NAT is happening on VPN 0, so give the NAT VPN ID 0, and the NAT interface is Gigi 0/2 we just saw, and you can click on search, and here you can see the NAT interface and private source IP address and private destination address and public source address and public destination address. So the packet comes from 3.4 with the public destination IP, let's say 206, and after NAT the public source IP address gets changed of the interface IP address of your public internet link. This one you can see the IP 201.87, so the same IP you can see here, The destination remains the same, 206, and you can also see the public port numbers, how many packets went out and coming. So this basically gives the NAT translation values happening. So that's the procedure how you can configure direct internet access using a centralized data policy. So basically what we achieved is in VH3 under VPN 10 there are two prefixes, 192.168.3.1 and 192.168.30.1. We enabled direct internet access only for one particular prefix using a centralized data policy. Now we will see how to configure Cisco SD-WAN DIA using NAT DIA route under your service VPN. So now I'm going to deactivate the policy so that the internet traffic stops working. So I just deactivated, and you can see the ping stopped working now to the public internet, and if you open any browser, so now it won't open. You can see it is getting timed out. Also from VH I'm not able to ping the public IPs. So now we will see how to configure Cisco SD-WAN direct internet access using a NAT DIA route. So in this method we will configure a default static route with a nest op of VPN 0 which will direct traffic coming from your service VPN 10 towards VPN 0 NAT enabled interface. That is the interface which is connected to your public internet access. So the difference between your the previous method, that is DIA configuration using a centralized data policy, is that we can specify a specific prefix from your service VPN to allow internet access. So in this method, that is the NAT DIA route method, once you configure a default static route on your service VPN, all the prefixes under that service VPN will get the internet access. So that's the difference between the two methods. Now let's configure the DIA using the NAT DIA route method. Let's go to the policies and confirm there is no policies enabled now. And let's go to the templates. So the only change we are going to make in our device template is that we are going to enable a default static route under the service VPN. So let's go to your feature template. I'm going to make only changes on the VPN 10 template actually here. Okay, this one DIA VPN 10 VPN template. So under the VPN template I'm going to make some changes. See, under the VPN template, under the IP route, I'm going to add a new route, a default route, and click on. So usually we given nest op, so for this we have to click VPN and enable VPN globally. I'm giving on. So we have added a default static route, and the gateway we given VPN. So what it will do is the traffic coming from VPN 10, from any prefix under VPN 10, it will direct to the VPN 0 NAT enabled interface. So that's the only change I'm going to add. I'm going to update this. So now this template is already attached to your VH3. So whatever changes I have done is going to get attached to VH3 now. Let's see the config difference, side by side difference. Only change, you will see a default route getting added. So you can see under VPN 10 there was no default route. So now we are going to see this new route, that is IP route towards VPN 0 is getting added under VPN 10, and that applies to both these prefixes. So the configuration is getting pushed now. Yeah, the config is pushed now. And you can see from VH3 now the destination towards 8.8.8 is reachable. And one difference we will see is that from 3.1 also we can reach. And 30.1 also we can reach. So in this method, whatever prefixes under VPN 10 will get the direct internet access. You can see from 3.1 also I can reach, and 30.1 also I can reach. So under show IP route, we can see a default static route, and you can see it's protocol NAT. Verify the ping from the PC. Yeah, I can reach. Also check the browsing is happening. Yeah, it is opening now. I can open different websites. Okay, now from vmanage, let's verify the NAT translations under VH3. Go to real time. Filters, show the filters. VPN ID is 0. Interface is GIGI2. Yeah, it is still happening. Yeah, from 3.4 and 3.8 we can see the traffic coming for internet. We can see still the traffic coming from private source address getting NATed to public source address to our interface IP address. So compared to the previous method, we just added a default route towards VPN 0, but here we cannot restrict a particular prefix, accessing the internet. That's the difference between two methods. Based on the requirement, we can use whatever feasible. So that's the procedure how you can configure Cisco SD-WAN direct internet access. We can do it by configuring a centralized data policy in which you can specify a particular data prefix can get a direct internet access. And the another method is NAT DIA route method, where you configure a static default route on under the service VPN itself towards your VPN 0 NAT enabled interface. Only difference is that when you use the NAT DIA method, NAT DIA route method, all the prefixes under that particular service VPN will get a internet access. Thanks for watching the video. Don't forget to subscribe to my channel and also share with your friends. Have a nice day.